Hello wonderful person, this is Anton, and in today's video we're going to be exploring the idea of very large objects in our universe. But we're going to start our adventure right here on our home planet Earth. This is going to be a multi-part video, several-part video, where we're going to be exploring the so-called superclusters, and we're actually going to talk about various very large objects in our universe. Welcome to What the Math. Now, the reason we're starting on our home planet is because I wanted to give you a kind of a visual idea of how large things really are in the universe. So we're actually going to start escaping our planet Earth, and we're going to go through a part of our solar system just so you can kind of see how big it is. I'm also going to enable the orbits here so you can kind of see the size of our solar system. So this is our solar system. This is the sun in the center, and that's essentially how big it is. Obviously, if I start moving out of the system, we're going to reach something known as the star cluster, and this is the local star cluster group where many different stars, including Proxima Centauri and this right here. Oh no, maybe not this. This is Alpha Centauri, the neighboring star to Proxima Centauri, and of course a lot of other stars like Sirius and Procyon and so on and so forth. All of these other stars form the local star cluster. As you keep moving out and as you sort of escape this area, you'll realize that there's a lot more stars here, and eventually you'll basically be able to leave our galaxy. Now, this is probably very well known to you. This is the shape of our galaxy, and this is sort of often assumed to be the largest sort of object in our universe by many people that have studied astronomy maybe a long time ago, or haven't really learned about new things that were discovered in the last 5 or 10 or so years. So this galaxy, the Milky Way, it's not the biggest galaxy, but it is a relatively large galaxy compared to some of the neighboring galaxies, which are right here. These are so-called dwarf galaxies. Now, in this particular area, there's actually quite a lot of them. There's specifically about 54 of them, and 2 of them are large galaxies. One of them is our beautiful home, the Milky Way, and the other one is, and I'm trying to find it right now because it's kind of hard to see, it's actually right there. The other one is called Andromeda. So Andromeda is a little bit larger than our own galaxy. This is the Milky Way, and that right there is Andromeda. So altogether, this forms what's known as a local group. This is basically a collection of galaxies orbiting some kind of a Berry center in the middle here, and basically they're connected to each other with gravity, and they will stay together for many billions of years, and they might even collide, they might even undergo some other changes, but they will stay together for a very long time. But let's actually zoom out a little bit more, and we're going to move even further away. And as you move out, you'll actually realize that not only are there more local groups, or I guess smaller collections of galaxies, but there's actually a very large collection of all of these galaxies together. And this collection of galaxies is actually known as Virgo Cluster. You can kind of see them, all of them right here. It's a very sort of a large structure. And Virgo Cluster is actually about 53 or 54 million light years in radius, and it is relatively large. So we're currently about 54 million light years away from the Milky Way, and so this is how big Virgo Cluster is. It's sort of a very large formation of many different galaxies, many different groups of galaxies together. And the brightest galaxy here is known as Messier 8049, or also known as M49, and you can kind of see it right there. It's sort of the brightest galaxy in this particular cluster, and it is quite easy to see if you have a powerful enough telescope. But that's not it. This is just the beginning of the so-called largest structures in our universe, because we actually have recently discovered, or about, I think it was about 2-3 years ago in 2014, we've discovered that there's actually something even larger than that. And this larger object is now known as Laniakea Supercluster. And I'm going to try to kind of demonstrate to you what or how big it is, because it doesn't actually still exist in space engine. A lot of these galaxies are actually procedurally generated, so it will be very hard for us to actually see it. But it is actually something like 5 times larger than Virgo Cluster, and it does contain something like 100,000 different galaxies. Virgo Cluster only contains about 2,000. This contains a lot more. So we're going to actually move away from, so that's the Milky Way. We're going to move away from the Milky Way, and I'm going to try to demonstrate to you how big this object actually is. So I need to move away from our Milky Way at a distance of about close to about 500 million light years. The Milky Way is actually right on the edge of Laniakea Supercluster, and you can kind of see it in the picture that's on your screen right now. And what you're actually seeing in this picture, those lines, they're not actually real. Those indicate the motion, or specifically the vector of motion for various galaxies here. So, this supercluster is tremendously big. It is huge. It is absolutely enormous. But it is not actually the largest one, but it is nevertheless very big. So I'm currently at a distance of about 510 million light years away from our Milky Way. And what you're seeing right here, all of this stuff together, this is essentially the Laniakea supercluster. It contains over 100,000 galaxies. It contains a lot of mass. It also contains a lot of really interesting, mysterious things like the so-called Great Attractor, which is the area that is somewhere right here. I think it's somewhere right here. It's a very interesting empty space that has unusually high gravitational attraction, and it actually attracts many different galaxies toward its center, including the Milky Way. We're actually moving toward it at a speed of about 200 kilometers per second, and it's constantly increasing. So we're actually attracted to something in the middle there, but we'll talk about the Great Attractor in some other video. Now, these superclusters are actually quite common in our universe. There's estimated number of about 10 million of them. And the largest ones are absolutely huge. They're actually so big that it's even hard to demonstrate in Space Engine. But what's really interesting is that their boundaries or their borders are actually kind of hard to define because they're not really connected to each other. All these galaxies are not really connected to each other gravitationally, but they do seem to have somewhat common motion. They're moving towards something and they're moving away from something. So basically, in case of Laniakea, it's defined as the collection of various galaxies around the so-called Great Attractor. Basically, the Great Attractor is what defines our supercluster, whereas for some other superclusters, it can be something completely different. And what's really interesting is that with time, the dark energy will very likely rip this whole supercluster apart, and all of these galaxies will basically become isolated. But this is, of course, something that will happen billions of years in the future. And possibly might not even happen, because we might actually have a very good idea about what dark energy really is and how it works. But current prediction is that in the future this will actually disappear. But nevertheless, despite the fact that it's actually kind of hard to define the borders of the supercluster and many other superclusters, it is definitely currently, at least, the one of the largest structures in the universe and is absolutely tremendous in size. And the word itself, Laniakea, is actually Hawaiian for immense heaven, because basically this is how big and this is how huge this object really is. You know, traveling from here, where I currently am, back to our planet Earth, it would take us 520 million years if we were to travel at the speed of light. That is a very large object. So large, as a matter of fact, that in comparison to the actual size of the universe, it's only about 5% or so smaller than the actual universe. So it is a very immensely large and very hard to understand and to comprehend object. Now, one day we might be able to find some other techniques to study this particular supercluster and possibly even define its borders a little bit more. But for now, that's essentially all we know about it. We know that it's a collection of many different galaxies, all kind of related or connected to the so-called Great Attractor in the middle of the supercluster. And on the outskirts of the supercluster, right about there, that's where our galaxy is, and that's essentially where our planet Earth is as well. Now, this is essentially all I wanted to show you in this video. It's unfortunately very difficult for me to actually show you the actual supercluster, because many galaxies here might be a part of a completely different supercluster. But this picture that you see again is essentially one of the best current definitions of what Laniakea supercluster is like. And anyway, let's actually return back to the Milky Way. We're going to move through the supercluster and we're going to see the collection of galaxies and different stars in those galaxies as we pass through all of this stuff. And this is right here, our home, the Milky Way. And anyway, I hope now you know something more about various large structures in our universe, and you know what they kind of are and how they're defined in relation to other objects in our galaxy, in our universe, and everywhere else, of course. In one of the future videos, we're actually going to talk about other superclusters as well, and we're actually going to try to also discover the Great Attractor and speculate about what it could possibly be, because that's essentially the center of our home in Laniakea. Anyway, thank you so much for watching, and hopefully you enjoyed this video. And if you did, don't forget to subscribe, don't forget to share this video with your friends, and in the comments below, let me know if you know any other really large structures, or if you know of some other mysteries in the Laniakea supercluster except for the Great Attractor, so we can actually explore it in one of the future videos. Thank you for watching, I'll see you later, bye bye.